So in this case, this was similar to a famous rule we call in lambda calculus, which is alpha renaming. In order to think about it, so parallel that I can draw between imperative programming and functional programming is the scope. The value of the variable is the nearest, is its innermost scope. So in this case, x is 5, and then over here x gets kind of like the value of x changes to, not changes, but like there is a new x that becomes 6. But then when you're referring to this one, you're still referring to the let expression from above. So it's kind of like which let binding to use is a little confusing, but make sure to remember that it's always the innermost one that it binds to. So in this case, it would be 11. Now let's try to do some other ones where it's like let x equals 5 in let x equals 6 in x. Right. So what do you think the value of this x? What do you think the final value of x is going to be in this case?
6.
Yes, it is 6. But can you explain why?
Because the x is inside the parentheses with the let x equals 6.
Right. So what happens is in that case, so we reach in this, so it's kind of like so this was the expression that x equals 5 in that x equals 6 in x. So what happens is the second time it runs, it says let x equals 6 in x. This is the expression, this is the sub-expression it tries to evaluate. But it reaches a binding with the same name, so the rule is to, once it reaches the binding with the same name, you're told to not touch it. So in that case, the value of this just remains 6, it's not 5. Does that make sense? So the rule is basically to stop substituting when you reach a binding of the same name. Right. So are we clear about this, or would we like to do some more examples, like 1 or 2?
Might help.
Might help. Okay. All right. So if I have an example saying let x equals 5 in x plus let x equals 6 in x, what do you think the value for this expression is going to be?
It might just be 11.
Yep. Because this x was referring to this 5, even though it's the same name, but the scope is different. And then over here, x is 6, so 6 plus 5 is 11. Now let's try to do one more, and I think that should be good. So let x equals 5 in, and then let x equals 6 in 5 plus 5. Alright, what do you think the value of this one should be?
X equals 6 in 5 or in x?
No, in 5.
10.
Yep. Because you can't bind a number to another number. So that was the thing I was trying to tell you there. Now in this next case, let x equals 5 in let x equals 6 in 6 plus 5. What would this evaluate to? Yes.
5.
can you explain your reasoning behind 5?
So you can't find a number, so you can do 7 equals 6 and 6.
Well, I'm not binding. I can't bind one number to another number. It's kind of like mapping. But if the body and the number are the same, then yes, the final value remains like the value of x. So in this case, 6. Right. So now to go over functions. So functions are of two types. OCaml functions are not methods, they are not components of objects, and they do not have a receiver, so they are always called functions. So in this case, OCaml has two functions, two kinds of functions, recursive and non-recursive, as every functional language does. So there are two ways to, so in order to define a regular function, I can just use the let keyword again. So like let's say I want to add two numbers. So I say let add xy equals equals x plus y, and then I call it with 3 and 4. So that should give you 7. You could also, I think, put like, I'm just trying this out myself. Right, so you could also put parentheses, but it is actually not recommended to do that. It's just more confusing. So if it's not needed, don't do that. Don't add to code. Keep it simple. Be lazy. So that was one way to define an OCaml function. The other way is also to say something like let equals. Or actually, let me do an increment function. So let anything equals, you can use the fun keyword. Basically, I'm mapping every x to x plus 1. As you can see, this is a more mathy way of defining a function. But let us see whether this works, and then I call it with in 56 maybe. Right. So there are two ways of defining a function. One using, what matters is, if you notice in the two, I can just write it again. I can also write this as let x equals x plus 1, and right, so it gives me, so there are two ways. One of them you can use the word, the fun word, the keyword fun, and then the other way is just, which is a more mathy notation, like it's kind of like mapping all x to x plus 1. The other way is to just like put the on the left hand side, and you can like kind of like defining any other function. Now the second way that I did it is called syntactic sugar, officially, which is only, and what I mean by that is basically kind of pretty printing. Is anyone here familiar with Haskell? No. Okay, so this is just called pretty printing, which means it renders in a nicer format, which is readable, versus this one is, depending on the size of the function, these can get harder and harder to read. Right, so the other type of function is a recursive function. So let us write a recursive function. The way to write it is in addition to like the name of the function, you also mention that it is a recursive function definition. So you write let rec, and then I'm going to do the factorial of the number. So I want the number n equals if n equals 0, which is the single equality because you're checking for structural equality over here. If n equals 0, then 1, else n times factorial n minus 1. Right, our favorite recursive function. So now if I say factorial 5, it prints out 120. Can someone help me write the like a recursive version of the calculating a power of a number? Just the way I did it, but a different mathematical computation. right, I guess we're writing it together. So again, I use the let keyword. You always need this when you're defining a function. I know that it is a recursive function. I give it the name of the function, which let's just say it is p of path, and then I give it the arguments that I want it to work with, and then I say. So what happens when you raise a number to 0? Like, what is the base case over here?
Just one.
Right, so if I say so I'm using it as x raised to y. So if y equals 0, then 1, else x times of x and y minus 1, right? And then if I call it with 2 and 3, so this should give me 8, and that gives me 8. So does that make sense? Right. So I talked about syntactic sugar, I talked about recursive functions. So they're defined using the rec keyword before the name of the function. The factorial function was an example. You can also specify types in the definition of the function. So now, like, let's say I said let rec power xy. You can also like specify that it is that x is if you want it to be an integer, you can say x colon int, y colon int in 2 separate parentheses. But it's also not needed because OCaml infers types for you from the final type. Mutually recursive functions can be defined using the AND keyword. Now the next thing we're going to do is anonymous functions, these are basically lambda expressions. I think you might have heard of this in computing code, writing lambda expressions. And writing lambda expressions is actually more fun in OCaml and less tedious than it is in C++. So it has the keyword fun at the beginning. This indicates transformation of input into output. Give me a minute. So I can also just define, over here I typed in like names of functions, but I can also just define functions using the keyword fun. So I said fun x map to x plus 1, which we know is our little increment function. Right, so this is one form of a lambda expression which I had done in the past. I just want to reiterate that you need to use the keyword fun instead of just like mapping it on. And it has no name. The arrow indicates transformation of input into output. We know that all functions are values, and that's why functions are actually not evaluated until they're applied until you apply an argument to it. Functions are only evaluated when you like in a sense in imperative languages like call it with something. Function body is not evaluated until you apply to a parameter. Right, and the last thing I want to go over is function application, which is basically a bunch of, so E1, E2, E3, all of the E1, En, identify, these are all different expressions. Do not add commas or parentheses with them, they're just write them as is. So the way this works is you evaluate all of these two, let's try to do one as an example. So can everyone see here? Yeah. Okay, so if my example is so if my example is this lambda expression fun x mapped to x plus 1 and you apply it with 2 plus 3. So the steps evaluation of this expression would go, so you evaluate all sub-expressions. There are 2 sub-expressions over here. Can this be evaluated any further? Yeah, because it's a function. So it's not evaluated just yet, x plus 1. And then you evaluate this sub-expression, you say phi, and you apply into this. So if you substitute the argument values for the names of the parameter inside the body of the function, so this would give you 6. Does that function application make sense? Alright, so that was the last thing that I wanted to go over. If you have any questions, now is the time to ask. Even if you have questions with getting OCaml and Dune set up, I can help with that as well. Yeah.
So when I was trying to run VTOL earlier, it worked in the past. That how would I try to run it? Just doesn't happen.
Yeah.
I'm not gonna be free right after this.
Sorry?
I'm busy right after this. Like, come to me.
Sure. So if we don't have questions, then class is done for today.
How do you define the power recursive function?
Power, so I gave it the arguments, and then the base case was when the power is 0 with 1, and then x times the power, x times y minus 1.
X times
X as 1 over standard, and then y minus 1 for the next one, because each time you want to reduce the,
parentheses x times y.
no, just,
What do you make it? I don't know. Like
just x times power.
pasta or chicken?
Oh,
Yeah.
I might have time.
okay.
I don't know, but I want to take my dorm. How are you? One of them is like kind of cool. One of them sits in the all day, one of them